Imagine stretching your arms out as far as they can go. From the tip of one middle finger to the other lies the entire 4.5 billion year history of Earth. Now look at your left hand. Everything you've ever learned about ancient Egypt, the Roman Empire, the Industrial Revolution, World War II, even the moment you're living right now. All of it fits on the very edge of your fingernail. For almost the entire history of our planet, there were no humans. No cities, no dinosaurs, not even plants. Just a violent world of fire, molten rock, and endless cosmic destruction. Yet somehow, against impossible odds, that lifeless inferno transformed into the only known world capable of supporting life. But Earth's journey wasn't peaceful. It survived planet-sized collisions, global ice ages, catastrophic extinctions, and disasters powerful enough to erase almost everything that had ever lived. And every one of those events shaped the world beneath your feet today. This is the complete story of Earth's evolution, from a burning ball of molten rock to the rise of humanity in just a few minutes. 4.5 billion years ago, there was no Earth, no oceans, no continents, no life. Only a young sun burning at the center of a swirling cloud of gas, dust, and shattered rock left behind by the birth of our solar system. Over millions of years, gravity began pulling those scattered fragments together. Every collision made the growing world larger, hotter, and more violent. Eventually, the newborn Earth became a glowing ocean of molten rock, with temperatures so extreme that nothing solid could survive. Then, disaster struck. A young planet roughly the size of Mars slammed into Earth at unimaginable speed. The impact was so powerful that it ripped billions of tons of molten rock into space and permanently tilted our planet on its axis. From that catastrophic collision, the Moon was born. Its gravity would go on to stabilize Earth's rotation, control the tides, and quietly shape the future of life itself. As millions of years passed, the bombardment slowly began to fade. The surface cooled, thick clouds filled the sky, and rain poured for thousands of years without stopping. When the storms finally cleared, Earth's first oceans had formed. For the first time in its history, our planet was no longer a world of fire. It had become a world of possibility. The first spark of life. The oceans had formed. The relentless bombardment had slowed. For the first time in Earth's history, the planet was stable enough for something extraordinary to happen. Deep beneath the surface, far beyond the reach of sunlight, cracks in the ocean floor released scorching water rich with minerals and chemicals. These hydrothermal vents became nature's first laboratories. Here, simple elements like carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus collided under intense heat and pressure, creating increasingly complex molecules. Over millions of years, those molecules began organizing themselves in ways no one had ever seen before. Then something almost impossible happened. One of those tiny molecular structures gained the ability to make copies of itself. It wasn't alive the way we understand life today. It had no eyes. No brain, no heartbeat, but it could reproduce. That single breakthrough changed everything. From that moment onward, life never truly stopped evolving. Every tree, every fish, every dinosaur. And every human being can trace their origins back to those microscopic chemical reactions hidden beneath Earth's ancient oceans. Life had finally begun. For more than 1 billion years, life remained incredibly simple. Tiny single-celled organisms drifted through Earth's oceans, quietly multiplying with little change. Then, around 2.7 billion years ago, one microscopic organism changed the course of history forever: cyanobacteria. These tiny microbes evolved an extraordinary ability, photosynthesis. Using sunlight, water, and carbon dioxide, they began producing something that had barely existed on Earth before: oxygen. At first, it seemed like a miracle, but for almost every living organism on the planet, oxygen was actually a deadly poison. As billions of cyanobacteria spread across the oceans, oxygen slowly flooded the atmosphere. Ancient microbes that had ruled Earth for over 1 billion years began dying on a massive scale. This became Earth's first mass extinction, the Great Oxidation Event. Yet from catastrophe came opportunity. The few organisms that adapted to oxygen gained access to an entirely new and more powerful way of producing energy: Life became stronger, more complex, more resilient. But Earth's transformation wasn't over. As oxygen replaced methane in the atmosphere, the planet lost much of its natural greenhouse blanket. Temperatures plunged, ice spread from the poles toward the equator. Eventually, glaciers covered nearly the entire planet. Earth had transformed into a frozen world. A giant snowball drifting through space, and once again, life somehow survived. Earth had survived frozen oceans, poisonous air, and multiple global catastrophes. But beneath its surface, something even more remarkable was unfolding. Around 1.8 billion years ago, Earth's continents slowly merged into the planet's first known supercontinent, Columbia. It was a barren world of rock, volcanoes, and endless coastline. There were no forests, no animals, not even grass. Yet beneath the ancient seas, evolution was preparing its greatest breakthrough. Some primitive cells began doing something that would change life forever. Instead of competing, they started working together. Larger cells absorbed smaller bacteria, but instead of digesting them, they formed a partnership. Those tiny bacteria became mitochondria, the microscopic power plants that still exist inside nearly every cell in your body today. For the first time, cells had enough energy to become far more complex. They developed protective membranes, specialized structures, and a central nucleus to store genetic information. These new cells became known as eukaryotes. And from these humble beginnings came every plant, every mushroom, every animal, and eventually, us. Life was no longer just surviving, it was preparing to conquer the planet. But Earth itself wasn't finished changing. The continents were constantly moving, breaking apart, then crashing back together again. Around 1 billion years ago, nearly all of Earth's land united to form another enormous supercontinent, Rodinia. It stretched across the equator, creating a dry and lifeless world unlike anything we know today. But Rodinia's greatest impact wasn't on land, it was on the climate. As the supercontinent began breaking apart, Earth's weather changed dramatically. Heavy rainfall lasted for millions of years, pulling enormous amounts of carbon dioxide out of the atmosphere. Without enough greenhouse gases to trap heat, the planet began to freeze, ice spread across the oceans, glaciers advanced toward the equator before long. Earth had become a frozen world once again. Scientists call this period Snowball Earth. From space, our planet may have looked like nothing more than a giant white marble drifting silently through the darkness. Yet beneath kilometers of ice, life endured. Hidden within the oceans, protected by geothermal heat and deep underwater environments, evolution continued its slow, relentless march forward. And when the ice finally melted, life exploded in ways the world had never seen before.